Symmetry Calc. This lesson is going to help us put together a bunch of ideas. I feel like we've learned a lot of different strategies and ways of looking at quadratics. Let's just tie all those ideas together so that they're clear in our mind. So first of all, I have this quadratic right here. And algebraically, they want us to find when f of x equals 10. Okay, so we've done this a lot in chapter 2. F of x equaling 10, 10, okay, is the output. And the output is the y value. Okay, so should I put that into the x's? No, that's the output. Okay, so 10 is going to go right here into this f of x spot. And they did say to algebraically do this, so I know I need to move everything to one side. Should we move it to the left or the right? Let's definitely move everything to the left so that the leading coefficient is positive. Okay, that's going to make all the factoring a lot easier. That'll be negative 6x minus 18 plus the 10 will be minus 8. Okay. Now, how are we going to solve? Okay, definitely have to factor because it's a quadratic, 2 answers. But you know what? I noticed they're all divisible by 2. So the first thing I'm going to do is take out a 2 and make my factoring job just a little bit easier. There's a variety of ways of doing this factoring. Okay, so guess and check might be the way to go since it's just x squared. Should the 4 be 1 and 4 or 2 and 2? I think it should be 1 and 4 because that's a 3. And who gets the negative? I think 4 is going to get the negative, and 1 will get the positive. Let's just check by doing outers and inners. Yes. Okay. So algebraically find when f of x is 10. So when does that happen? That happens when x is equal to negative 1, and that happens when x is equal to 4. Okay. Are these x-intercepts? No, these are not x-intercepts. This is when f of x is 10. Okay, so these are solutions. Okay, to when you're equal to 10. Solutions when f of x is equal to a 10. Okay, so let's go look at this graphically. What does that mean? At negative 1, okay, where's the graph? Oh, right there. Negative 1 takes us to 10. Okay, and then what other number takes us to 10? Oh, 4 takes us to 10. Okay, and those are the same solutions we got up here. Okay, use the graph to find when x equals 10. So here's the value of 10, and that does happen 2 times. Okay, so we could write this a variety of ways. We could say f of negative 1 takes us to 10, and f of 4 takes us to 10. Okay, we could also write them in point form because that's when you get a value of 10. Okay, so graphically, you'd want to look on the y-axis to find the x values. Algebraically, you could solve it. Okay, so how do you do the work when you want to find when a function equals a value? Okay. So here's what we do, okay? Plug the value into the y spot. Okay, step 1. Step 2, make the equation equal to 0. Make it equal to 0, okay? And move everything where your life is easy, okay? Always try to make leading coefficient positive. Always try to make the leading coefficient positive, okay? And then show off those awesome factoring skills, right? Okay, factor away. Factor. Okay, let's go to the next page. How do you do it when they algebraically want you to find f of x equals 0? Okay, so that is a y value. Once again, that's an output. An output, and I'm going to put that value into the f of x spot. F of x spot, okay? So I notice this is a quadratic equation. This is a quadratic. It's going to get two answers, okay? And we're supposed to move everything to one side. Everything kind of is on one side. I don't really want to factor with a negative, though. Am I allowed to just change him to a positive? No. Am I allowed? What if I just change everyone? Does that seem fair? If I just change everyone to the opposite? Essentially, what that would be like doing is moving everyone over to the other side. Look, I just made him positive. I just made him negative. I just made him negative, okay? So if you want, you can multiply both sides by a negative, okay? Or you could just move everything over. But there you go. That's going to be a lot easier to work with. We still have to factor. The quadratic equation has two solutions. Let's factor out the 2 first. Okay, so remember, whenever you do factoring, okay, take out the GCF first. Now this is a nice, easy factoring problem with x and x. The only way to make a 5 is a 5 and a 1. And the 5 is going to get the negative, 1's going to get the positive. Okay, so when does f of x equal 0? Okay, when x is equal to 5 and when x is equal to negative 1. That's when. We could also say f of 5 makes a 0. F of negative 1 makes a 0. Let's go take a look at the graph and see if that's true. Okay, when I look at my graph, when is the graph equal to 0? When is it equal to 0? Not above 0, not below 0. So we're looking right here at the x-axis, and there's 2 times. Okay, right here at negative 1 comma 0, and the other one is 5 comma 0. Okay, and those are the x-intercepts. So the x-intercepts are negative 1 comma 0 and 5 comma 0. It's very similar to the last page we just did, okay? But instead of having a value and then moving everything over to make a 0, it's like we're already starting with the 0, okay? So how do you find when a function is equal to 0? Okay, so step 1, plug in 0 for the y, okay, or the f of x. F of x, plug 0 in. Okay, so everything is already on one side. Step 2 is factor. Awesome factoring skills again. Okay, so we've learned a lot of things so far. And let's put them in this nice little chart. How do you find the vertex? Okay, now that we have all these different strategies, people tend to mix them up a little bit. Okay, so the vertex is right there. A vertex is called h comma k. It's not an x-intercept or a y-intercept. It is the maximum or minimum point. Okay, and there's actually 2 ways you could do this. You could find that by completing the square. You can complete the square to find the vertex. Or you can use h and k formulas. Okay, we just have to be careful with when we use things. The most common mistake is people will say, I'll use h and k formulas down here. No, that's not a vertex. Okay, the second thing is, what if y equals a value? Okay, and that's kind of what this line right here shows. Okay, what if I'm trying to find when you equal a value of 7? How do you find a value? Okay, so you plug the value into the y spot. You make the equation equal to 0. Make it equal to 0. Move everything over, and then we factor. And that's how you solve for when you're a value. And then you'll get these 2 solutions. Okay? What if you need to find the zeros, or the roots, or the x-intercept? So that's 3 different ways. Zeros, we could call them roots or x-intercepts, and that's these points down here. Okay, I know why they're called x-intercepts, because they're touching the x-axis. Sometimes they're called zeros, okay, because the y number is always 0. It's where it zeroes out. They also call those roots. Okay, and how do you do that? You plug 0, okay, into the y spot. Make the y equal 0, which kind of picks up right there at step 2, and then you have to factor. Okay, if factoring doesn't work, guys, what do we have to do? Okay, yeah, we might have to use the quadratic formula. Okay, if factoring doesn't work, oh my gosh, let's add that to this right here. You might have to use the quadratic formula if the answers are irrational. Okay, let's do a couple more examples. Okay, so I have this parabola right here. Let's find the vertex. We're going to find everything about him and put it all together. Find it by completing the square. Okay, so completing the square, let's use pink for vertex. F of x equals, the first thing I'm going to do is get the x squared alone, so I'm going to factor out a negative, and that gives me x squared minus 8x. Negative 12 gets pushed just way off to the side. Half and squared, half of that's negative 4 squared, so that's a plus 16, but actually it's negative 16 in disguise. I will compensate with a positive 16. So f of x is negative. Quantity squared plus 4, this is x minus 4. Okay, so the vertex is at 4, 4. Now down here you notice it also says find the vertex by using h and k formulas. Okay, let's practice. We could also have done h and k formulas. It's going to give us very similar answers, right? Or actually the exact same answers. Let's just try a different strategy. H is negative b over 2a. So negative 8 over negative 2, that gives me a 4. K is c minus b squared over 4a. Let's cancel a negative and a negative. 4 cancels 8 to make it 2. So we're getting negative 12 plus 16, which makes a 4. Okay, so either way you choose to do vertex, you should get 4, 4. Okay, let's go graph that right away. The vertex is at 4, 4. 4 to the right, 4. There's the vertex. Perfect. Okay, what else do we have? Let's find what f of x equals a 3. When f of x equals a 3, so that's the output. The output is going to go into the y spot right there. So 3 equals equation. When does the equation equal a 3? Oh, hang on. I got to move everything to one side first. Let's move it to the left. So that x becomes positive. Minus 8x plus 12 plus 3 plus 15 equals 0. Let's try to factor. If it doesn't, then we'll whip out the quadratic formula. Let's see, 15 and 1. That's not going to work. How about 3 and 5? Ooh, that looks promising. 3 times 5 makes a 15. And if they're both negative, it works. Okay, so we just found x is equal to 3 and x is equal to 5. That makes a value of 3. Okay, so we've got f of 3 makes a 3 and f of 5 makes a 3. Let's go plot those points on the graph. 3 gives us 3 and 5 gives us 3. Okay, so sometimes people go like this. At this point right here, this is a value of 3. The parabola is going to touch that value 2 times. Let's find the zeros. The zeros, okay, that's a fancy way of saying the zeros or the roots or the x-intercepts. Okay, so there's lots of ways of saying that. Okay, if I say find zeros on a test, that's the same as saying x-intercepts. And the way you find an x-intercept is you let y equal to 0. Okay, let y equal to 0. I'm going to change them all. I'm going to move everyone to the other side, or just change all of them. Change, change, change. All right, does this factor? I hope so. I hope so. If not, we have to do quadratic formula. Who thought you would have been hoping for factoring, right? Let's see. 1 and 12? No. 3 and 4? No. 6 and 2? Oop, that looks promising. 6 times 2. If they're both negative, that's going to work. That's going to work. So we've got 6, 0 and 2, 0. Remember, okay, intercepts. Okay, intercepts are points. Okay, so this graph touches the x-axis at 6, 0 and at 2, 0. Does this look good? Let's see. Let's write some equations here, and then we're gonna fix up that graph even more. Okay. The standard form is like when it's a, b, c, and that's the equation that was given to us. Okay, so that was negative x squared plus 8x minus 12. Okay, how about vertex form? Now that I see the vertex, let's go ahead and write vertex form, okay? Except this parabola was opening down, we still have to have opening down, okay? Vertex form shows us the vertex, so this would be x minus 4, quantity squared plus 4. Vertex form is awesome for finding the vertex. Okay, how about factored form? We kind of had that form up there. Factored form, f of x equals, we're going to have a negative out in front, and then we have x minus 6, x minus 2. So factored form is awesome, remember, for telling us the x-intercepts. Okay, they're all awesome for one reason. Vertex form is awesome for telling us the vertex. What standard form awesome for? What is he awesome for? He's awesome at telling us the y-intercept. The y-intercept is 0, negative 12. Whew, 0, negative 12. Wow, that's way down there. Okay, now by symmetry, if we have a number at 0, 12, does anyone know another matching point? Yeah, we're going to have one at 8, 12. 8, 12. So I'm looking at this. Does this equation have any vertical stretch or shrink? The answer is no. There's no vertical stretch or shrink. So over 1, down 1. Over 1, down 3. Over 1, down 5. Over 1, down 7. Everything is making sense and clicking together. I'm going to draw this awesome graph right here with our vertex, our x-intercepts, a random value, a little bit of everything, okay? This lesson was called Putting It All Together. Everything should click together. It's not going to fight itself. If something doesn't work, you made a mistake. Okay, let's go do one more just to make sure we're all on the same page. This equation has some interesting things happening. So to find the vertex, would you guys like to do complete the square or h and k? Let's do h and k. So h is negative b over 2a. 20 divided by 10, that's going to be a 2. K is c minus, remember, I don't ever multiply those. We have negative b squared here, 2 b's over 4a. So 2 of these negatives are going to cancel. Let's see, let's cancel 4 goes into 25 times, 5 into 24 times. And so we have 15 minus 20, which is negative 5. So the vertex is 2, negative 5. Let's go ahead and graph that right away. 2, negative 5. 2, negative 5. There we go. There's the vertex. V for vertex. Okay, let's see. What else? Find all intercepts. Ooh, look how they did that. Find all intercepts. So let's find x-intercepts. And then we also have to find some y-intercepts. Y-intercepts. To find an x-intercept, you let the y number be 0. And then we're going to factor. Let's make this problem smaller. Let's factor out a 5. Let's factor out a 5. X squared minus 4x plus 3. And I really hope this factors. I do not want to do quadratic formula. Let's see. Well, 3 and 1 is the only way to make a 3. Is there any way for that to become a negative 4 if they're both negative? Okay, so the x-intercepts are 3, 0, and 1, 0. Let's go get the x-intercepts on the graph. 3, 0, 1, 0. All right, what about the y-intercept? To find a y-intercept, you let x equal 0. So we've got 0, 0, 0, 15. Remember how the y-intercept is always the easy one? The x is the fun one. 0, 15. There's the y-intercept. Okay. Now by symmetry, if that's 1 point, let's see, where's another matching point? You're right, it's right there. Right there. We're at 4, 15. Okay, find when f of x equals 15. Oh, I think I kind of know the answer to that, but let's do the algebra work, right? When you have a value that's an output, we're going to put that into the y spot. Okay, and then we have to move everything to one side to factor. Let's move everything to the right side. So if I subtract 15, oh, that cancels out. Oh, sometimes when the problem gets smaller, people get stuck. Okay, it's the same process. It's still a squared. We have to factor. How do you factor when there's only 2 terms? We're going to factor out the greatest common factor. Use factor out. Let's take out a 5x, and that's x minus 4. So we're getting x equals 0, and we're getting x equals 4. Okay, so what does that mean? F of 0 would give us a 15, and f of 4 would give us a 15. Is that true? F of 0, yes, and f of 4, absolutely. Okay, so what we visually discovered on the graph, okay, we confirmed with algebra. That's how you find an output. Okay, I think we're ready to go ahead and graph this. Does this graph have any vertical stretch or shrink? Yes, it does. Okay, it has vertical stretch of 5. Stretch of 5. Okay, so a regular parabola would go over 1 up 1, over 1 up 3, over 1 up 5. But I have to multiply all of the up numbers by 5. So we're going to go 5, 15, 25. Let's go see. Over 1 up 5. Got it. Over 1 up 15. Wow. This graph paper just happened to be the perfect size, didn't it? Tall, skinny parabola. Okay, now don't touch the x-axis till you get to 15. Don't touch, don't touch, don't touch. I'm at the y-axis. Don't touch, don't touch. And then when you do, don't ride up the y-axis. Just gradually start to go wider, wider. Okay, don't veer off. Stay in that box. Same thing here. Don't touch, don't touch. Get closer, stay in the middle, stay in the middle. Oh. And then when you get here, you cross. Okay. State the domain. Now this parabola goes forever to the right, forever to the left. He has no breaks in him, so the domain is all reals. Okay, or you could say from negative infinity to positive infinity. How about the range? What about the y values? The smallest y value is -5. Okay, so brackets from -5 up to infinity. How about intervals of increasing, decreasing? Okay, so we've got intervals of increasing and decreasing. Okay, so this parabola is opening up. Whenever they do that, there's really only two sections. Okay, parabolas only have two parts to him. Okay, so I notice first, going from left to right, this parabola is going down, 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 down. It's decreasing down to its minimum point, and then it increases up. Okay, so the decreasing section, I'll do that first, goes from negative infinity, okay, and we're looking at x values all the way until 2. And then the increasing section starts at 2 to infinity. Okay, so you're looking at x values there, increasing. So this part of the number line is where the parabola was decreasing. Okay, and then this part here, these x values, is where it was increasing. Okay, I can use H and K formulas. I can use discriminant. I can, solve the quadratic equation. I can find max mins. I hope you can.